Good evening, everybody. I'm here to talk to you about some of the difficulties associated with the simplifying algebra when doing the quotient rule. Let's get down to it. So I'm going to use this Leibniz notation, and this is credited to a German guy. Let me see if I can keep my hand out of the way here for you. This reads ddx of x squared plus 1 over x squared minus 1, quantity raised to the 1/4. Now sometimes this appears as radical notation, or is it you might see it coming to you like this, the square roots. This is just radical notation again, and these two objects mean the very same thing. Now, it turns out due to something called the chain rule, it's much easier to write it like this, okay? Because the chain rule indicates you have a couple of functions. This function right here raises everything to the 1/4 power. That's called extracting the 4th root. And then there's this interior function, which is actually a quotient. And so looking ahead, you kind of can anticipate the chain rule along with the quotient rule coming into play here. So first step, first part of the chain rule says to drag this exponent around to the front. And then subtract 1 from 1/4. Well, 1 minus 1/4 is the same as 1 minus 4/4. So this would be to the minus 3/4 right here. Now at this stage of the problem, we're halfway done with the chain rule. But the second part of the chain rule says take the derivative of the interior function. And that's where this gets a little messy. Often the interior function, like say if it was sine x, you would just write down cosine x out here. But it's a little bit more involved. We have to take the derivative of this quotient, which few of us can do in our heads. So let's write this down as a work in progress. Now this is a step I really like, because I've seen people actually try to do this step in their head and write it down there. You're successful, but it's an unnecessary risk. You may be successful, unlikely though, but nonetheless, it's an unnecessary risk. So let's keep on going here. Now I'll just recopy this piece right here. Again, a lot of math is kind of clerical in nature. We spend time writing, but now we actually have to perform this operation, which involves the quotient rule. And so I will always forget if I don't do it like this. The quotient rule always involves the denominator squared in the denominator. Let me put a minus 1 there, and this is squared. So you see, we just took the denominator and squared it. Now, what we do is we take the top function, which is x squared minus 1, times the derivative of the top function. Well, we have a constant there. The derivative of a constant is 0. The derivative of this object is 2x. So we'll wrap this in parentheses. We'll write 2x there. Again, from here, you write down the denominator squared, and then the next part of the quotient rule is to take the bottom function times the derivative of the top function, okay, and then minus the other way around, minus the top function. But I don't run out of room here, folks. Plus 1 times the derivative of the top function. Okay? And again, it's worth your time to be kind of neurotic in mathematics. Take a look, make sure you've adhered to the rule. The rule goes low D high minus high D low. And so this is the low, this is the derivative of the high minus high D low. Okay? So again, folks, just a lot of kind of grinded out work here as far as writing this down. Okay, we have 1/4 x squared plus 1 over x squared minus 1 to the minus 3/4. Now again, this is just turns into a massive algebra problem really. You were done with the calculus at this stage of the problem. All right, but there's still quite a bit of simplification to do. Now, that will involve taking, collecting like terms here. Y'all, just kind of a word to the wise, it's a good idea just to write down this part of it first. Usually this part remains unaltered. Sometimes one of the factors will cancel or something, but generally speaking, that denominator remains squared. And is that minus 1? I keep forgetting that, folks. Yeah, that's minus 1 right there. Okay, minus 1. All right, now, so let's go here. We have 2x cubed. When you multiply this term against this term, minus 2x. Now, what you're going to have right here is minus 2x cubed. I hope this is legible for you. It may be a little too small. Let's see if we can expand that up a little bit. Okay, I hope that helped. All right, so this minus 2x cubed comes from here. And then finally we have minus 2x right here. Okay. Now, again, just be persistent. This is almost like a marathon run or something. You really have to hold your head up and be vigilant about not skipping any steps. So we've been copying this down. A lot of people don't like this aspect of mathematics. You don't want to have to recopy things when you don't feel like you're making progress, but otherwise it's hard to track what you're doing if you don't just write everything down. Now, a nice thing happens. This is a sign of a problem that you're doing something right, usually if you get simplification. Not always, but notice these two terms cancel. And what's left right here is minus 4x. Like that. Okay? All right, folks, so we're hopping along here pretty good. Now, you can see right here that this negative 4 and that negative 4 will cancel, just leaving negative x. And also, folks, what you can do, and this is laws of exponents right here, but this will result in, and I'll try to say as little as possible here, that 4 and that 4 cancels, give you negative 1, so you have minus x. Now what's going to happen here, properties of exponents, the minus exponent here indicates that this expression will come down and this will become positive. All right, and so what you end up with is x squared plus 1 over x squared minus 1 quantity to the 3/4. Right? Now notice that this piece is still in place right here. X squared minus 1 squared. Now, the age-old question in mathematics is how far is enough? How far is, it's kind of hard to know what the instructions simplify even mean sometimes. But as long as you see similar expressions in the exponents going on, you think that this might result in further simplification. Now, again, I can't give you a hard and fast rule about when to stop and when not to stop. But all I know is I see that x squared minus 1 to the 3/4 is right here, right? And you're going to have x squared minus 1 squared. So what's going to happen here? And y'all, let me see here if I'm going to, I don't want to run out of room on you. I think we're good here. But so you can recopy this is minus x. Now again, folks, how many steps do you show? I don't know. It's a tough question to answer. But what we have right here is x squared plus 1 raised to the 3/4 power. Now watch what's going to happen here. This one will come over and underneath this one. And again, that's just algebraic manipulation. So you have x squared minus 1 squared over x squared minus 1 to the 3/4. All right, folks, now we're just about done with this monster. This has been an endurance. I think I've lost about 75 calories here. That's okay, though, if you can lose that much sitting down, right? Now, good for diabetes. Now, so if we continue here, you're going to get minus x over x squared plus 1 to the 3/4. That doesn't change. But y'all, what do we have going on here? We have the same base, x squared minus 1 over x squared minus 1. So that means as long as you have the same base, even though it is a two-term base, you can subtract 3/4 from 2? Well, this isn't hard to see. 2 is the same as 8 over 4, right? And we need to write 2 as 8 over 4 so we can subtract 3/4 all the way back to intermediate algebra and common denominator. So 8 over 4 minus 3 over 4 is 5 over 4. And we've completed this monster. We have actually survived this thing. It doesn't look like I made any mistakes. So there it is, folks. And again, that's about as simple as it gets right there in terms of what can we cancel. This certainly looks a lot cleaner than this. And I don't have any strict guidance on what constitutes simplification. But again, I do want to repeat, this started out as just a calculus problem. Look, we were trying to find the derivative of this expression here. We were essentially done with the calculus piece of it right here. The rest of this is nothing but mad algebra. Look at that. See there? I mean, all of this is cold-blooded algebra, stuff that you're supposed to learn in college algebra, even though sometimes you really don't. But look, 1, 2, 3, 4, 5 steps of algebra. 5 steps of algebra, ladies and gentlemen. So anyway, now there is another approach to this called logarithmic differentiation, and I'm going to produce a video that does that for you. But I'm going to go ahead and sign off, and you guys have a good one. Be looking for, there's another way to do this, again, using logarithmic differentiation. I'll try to get that posted pretty quickly. All right, thank you and good night.